Good morning everyone. Today we are going to start a new chapter, that is the haloalkane and haloarene from the organic chemistry. Then when we start any chapter, we introduce that chapter, we will introduce the haloalkane and haloarenes. Then all those of the organic compounds which contains the halogens on it, they are considered as a haloalkanes if the alkyl group is there, and if instead of the alkyl group there is an aryl group, there is a benzene ring you can say, then in that condition that will be considered as a haloarenes. When you will see the general nomenclature for these of the compounds on the basis of the unsaturation, position of unsaturation, then the compounds may be named as, may be classified as see, this is the halogen. The carbon which is directly attached to the function group, that is called the alpha carbon, and the carbon next to the alpha carbon is called beta carbon. If there is a unsaturation on the beta carbon, this is a beta carbon and here it is a unsaturation. If there is unsaturation on the beta carbon, it will be considered as a allylic halide. But if you are seeing another compound which have the same position for the halogen, but the unsaturation is not at the beta position, is at the alpha position. If that is happening, if the alpha position is carrying the unsaturation, then in that condition the system will be called vinylic halide. But it's not in the case of the benzene ring. If there is a benzene ring, the condition will be totally different. So we are seeing what will happen if there is a benzene ring. See, this is the benzene ring carrying halogen. This is the carbon containing alpha carbon, halogen is called the alpha carbon, and this is the beta carbon which is unsaturated. You can see this is the unsaturation. And as the beta carbon is unsaturated, it will lay in the category of the allylic halide. But when you will see the condition of the benzene ring, the double bond of the benzene ring is not as freely available as in the case of any of the alkyl system. So that will not give the same property whatever the allylic halides are giving. So the compound is not considered as a allylic halide, that is considered as a benzylic halide. Benzylic halide. When the beta carbon is unsaturated, but the beta carbon is the part of the benzene ring. But what happens when the alpha carbon is unsaturated, but that alpha carbon is the part of benzene ring? See, this is the alpha carbon and this is the part of benzene ring having unsaturation too. That means it is also following the condition for the vinylic halide, but it is a arene, it is a benzene system, and so it will be called aryl halide. Then this is the general classification of the halides on the basis of the position of the unsaturation, on the basis of the position of the halogen with respect to the double bond, you can say. Then these are the four different type of the halides which you will have to study. Now we are going to study about the preparation of the haloalkanes and haloarenes. So in preparation, the first preparation we are going to see is the preparation from alkene. How will you prepare the haloalkane from alkene? The reaction is well known to you. We have started the organic reactions with the same reaction in class 10 and as well as in the class 11th when we have studied about the chemical property of the alkane. So we are going to study the preparation of haloalkane with the help of the alkanes. I am taking methane as an alkane. When it is treated with the halogen Cl2 in presence of light represented by the H nu is representing the presence of light. In presence of light, it will form the substituted product CH3Cl along with HCl. If you want to see the mechanism, the reaction runs through the free radical mechanism. I am just showing you the mechanism. But remember, only when your question is saying that write down the mechanism for the following reaction, only then you will write the mechanism. Otherwise you don't have to write any of the mechanism for any reaction without any reason. If they are saying write down the following reaction, you just write the reaction. Don't write the mechanism for reaction without saying that write down the mechanism for the reaction. That means only when your question is saying to write the mechanism for the reaction, then only you will write the mechanism. Otherwise you don't write the mechanism of the reaction. Here I am going to write the mechanism for the reaction. Then first of all, what is mechanism? Mechanism means the pathway of any chemical reaction is called mechanism. That how any reaction proceeds, what is the pathway of the reaction. Then what is the pathway for this reaction? The reaction starts with the generation of attacking group. There are two reactants, you have already studied in the last year, that is the class 11, that there are two type of the reactant. The first one is called the attacking group and second one is called the substrate. Then the first step will be the generation of the attacking group, and here it is the chlorine reacting with in presence of light, and in presence of light the bond fission will take place, and that bond fission will be the homolytic bond fission represented with the help of the hook arrow, and it will form Cl free radicals, two Cl free radical. Now this Cl free radical will approach at the methane. When this Cl free radical will approach at the methane, then in presence of this free radical, the bond cleavage will take place, the homolytic bond cleavage will take place, and this chlorine, the chlorine free radical can approach either on the hydrogen or on the carbon. I am just trying to approach it on the hydrogen. You can also show the approach of the chlorine on the methyl group. So if this chlorine is approaching on the hydrogen, it will form HCl. What will be the remaining? The CH3 will remain here, and this one contain an unpaired electron, that is the methyl free radical. Now this methyl free radical will again approach to Cl2, and in presence of this free radical the homolytic bond cleavage will take place, and again the CH3Cl will be formed along with the chlorine free radical. This chlorine free radical will again approach on the system, will again approach on the methane, will form the same system, and this process will continue. So the first step is called the initiation. There the initiation of the reaction is taking place, and the second step and third step is considered as a propagation. Here the propagation of the reaction is taking place, the reaction is getting propagated, यानी कि आगे लगातार continue चल रहा है, the reaction is proceeding. Finally the reaction will complete, and the time to close the reaction, to terminate the reaction. So the last reaction will come, and that reaction step will be considered as a termination step. So we are going to see the last step, that is termination. At the end, that means on the completion of the reaction, you will find that some of the free radicals will remain there, hydrogen free radical, methyl free radical, chlorine free radical, and these are the free radicals will combine with each other, and after combining they will form hydrogen, ethane and chlorine like species, and in this way all the free radicals will be consumed, and after the consumption of free radical there will be no further reaction. So this step is called termination. These two steps are the propagation, and this one is initiation. So in these of the three steps the reaction proceeds. In this reaction it is asked during halogenation of methane. This is the process of halogenation of methane, where methane is halogenated with is chlorinated to form the chloromethane. Question is, during halogenation of methane, why a small amount of ethane is also formed? Then why it is formed? You can see with the help of the mechanism that in this step you can see methyl free radicals are formed. and the formation of methyl free radical is continued over full reaction. So sometime, maximum time, the chlorine approaches the chlorine, the methyl group approaches the chlorine free radical, and as a result they form the chloromethane. But whenever this methyl free radical approaches the another methyl free radical, it forms the ethane. Even the amount of this species is very small, but the formation of ethane takes place because of the formation of the methyl free radical. So during the halogenation of methane, a small amount of ethane is also formed because of the formation of the methyl free radical, which on dimerization forms the ethane. I think it's clear to all of you. You can note it down. Then we have seen the preparation from alkane. Now we are going to see the next preparation, that is the preparation by alkene. The reaction is very simple. Just take the alkene and treat it with the halo acid. You will find the halo alkene. Then this is the alkene CH2 double bond CH2. When it is treated with halo acid, here it is chloro compound, chloro acid, hydrochloric acid, it will form CH3 CH2Cl, a addition product. The alkene is called symmetric alkene. That means both the carbons are identical, both the carbons containing double bonds are identical. But if there is any unsymmetrical alkene, CH3 CH double bond CH2, you can see both the carbon which are unsaturated, they are not identical. Such type of species are called unsymmetrical alkene. When any unsymmetrical alkene is treated with halo acid, then what will be the product? In the previous one, both the carbons were identical. You can approach, you can provide the position for any of the element at any position. That means at any position bromine and any position hydrogen, or any position halogen, any position hydrogen. There's no any problem. यहाँ पे किसी को किसी भी पोजीशन पर रखिए, चाहे हाइड्रोजन को किसी पोजीशन पर रखिए या हेलोजन को किसी भी पोजीशन पर रखिए, कोई प्रॉब्लम नहीं थी. बट व्हेन यू विल सी द unsymmetrical alkene, यहाँ पे जरूर प्रॉब्लम है, because both the carbons are not identical system. The one have primary nature, one have secondary nature, one have the another stability of the carbocation, another have the another stability of the carbocation. So when you will see, then where the halogen will approach and where the hydrogen will approach, the solution comes from a rule called Markovnikov Rule. Last year में आपने पढ़ा था. The Markovnikov Rule says the more electronegative element approaches at the unsaturated carbon having lesser number of hydrogen. So when you will see this compound, these are the two unsaturated carbons. This one have 2 hydrogen and this one have 1 hydrogen. Then according to Markovnikov, the more electronegative element, here it is the bromine, the more electronegative element will approach at the unsaturated carbon having lesser number of hydrogen. Here it have a lesser number of hydrogen to form the addition product. So the addition product will be CH3, CHBr and CH3 according to Markovnikov Rule. Markovnikov Rule. I think it's clear to all of you because you have already studied in the lower classes in class 11 then what is the Markovnikov Rule. But if we are assuming that you want to get a product where the halogen is on position number 1, यहाँ पे जो प्रोडक्ट बना वो है 2-bromo-propane. लेकिन अगर आपको रिएक्शन में पूछ दिया है हाउ विल यू प्रिपेयर 1-bromopropane from propene, then what will you do? For that purpose there's another rule called Kharas effect or Anti-Marponica Rule. According to Kharas or according to Anti-Marponica Rule, when the same reaction proceeds in presence of peroxide, it leads to the anti-Marponica product. That means the more electronegative element approaches at the carbon having greater number of hydrogen. So here we are taking the same reactant, the CH3CH double bond CH2 plus HBr in presence of peroxide. Which peroxide? Generally we take a bulkier peroxide, generally we take the benzoyl peroxide. So in the presence of peroxide, the Anti-Marponica Rule will be followed. And what is the Anti-Marponica Rule? According to Anti-Marponica Rule, according to Kharas effect, the more electronegative element, here it is the bromine again, the more electronegative element will approach the unsaturated carbon having greater number of hydrogen. So in these two you can see that this carbon, that is the carbon number 1, have greater number of hydrogen. So the bromine will approach on the position number 1 and your product will be CH3 CH2 CH2Br. Generally we find that this rule is followed especially by the HBr. Other species can also follow the rule, but HBr is the best reactant for this rule, for the Anti-Marponica Rule. So this is the Markovnikov according to Markovnikov Rule, and this one is according to Anti-Marponica Rule. That is also known as Kharas effect. Then how they are giving the different product? The one is giving the product on the position number 1, that is the Anti-Marponica, and Markovnikov is giving on the position number 2. How will you explain that why Markovnikov is leading another product and Kharas is leading for the another product? So for that you must have to study about the mechanism. I have already said you will write the mechanism only when you are asked to write that. But I am explaining almost every mechanism which is necessary, because without explanation of the mechanism you are not able to understand that how the reaction is proceeding, how you are getting these of the products. So I am just explaining about the mechanism, that how the reaction is proceeding, how this effect is working. Otherwise there is no need of these of the mechanisms. I am just explaining that you can easily understood that what are the reactions are taking place. So next time we will see the mechanism for the Markovnikov as well as for the Anti-Marponica Rule. Till then, bye. Have a nice day.